Hi guys, welcome back to our digital VLSA channel. Hope you are all good. In this tutorial, we will discuss about gated D-Latch and its functionality. Before going to this, we will discuss about gated SR-Latch also, and then we will go to D-Latch and its functionality based on its truth table and timing diagram. So let us see about SR-Latch, which is gated. So why I call gated is I put enable signal as one of the input here. So let us write truth table so that you can easily understand by looking at truth table. E S R Q and Q bar. Okay. As you know, latch in the sense means when enable is high, the output follows the input. When enable is low, the output remains as it is and it holds the previous value. Enable, but except when is 0 or 0, we will see as an output holding its previous value. S or Q bar. Okay. Now when let us see enable is 1 and S 0 or 0. NAND is sensitive to 0, so it will produce 1 here, right? Now let us see next state and previous. Let us assume the previous outputs are 1 and 0. Okay, here 1 will come, 1 into 1 is 1, 0 or 0, 0 into 1 is 0, 0 bar is 1. So what you observed, next state is equal to previous state. So we can write it as Q and Q bar itself, right? Okay. Now, again enable as 1, S as 0 and R as 1. S 0 R 1. 1 into 0 is 0, 0 bar is 1, here 0. And then it is sensitive. The the NAND gate which is at bottom is sensitive to 0, so it will produce output as 1. This one goes here, and 1 into 1 is 1, 1 bar is 0. So always when it's 0 or 1, always we get output Q as 0, Q bar as 1. So this state is reset state. Okay, this state is reset state. Now let us keep enable as 1 and S is 1 and R is 0. This is the NAND gate which is at bottom is sensitive to 0, so it produces 1. 1 into 1 is 1, 1 bar is 0 here, and yes, this NAND gate is sensitive to 0, so it will produce 1. 1 comes to here, and 1 into 1 is 1, 1 bar is 0. So always Q and Q bar are 1 and 0 when inputs are 1 and 0. That means when S equal to 1 and R equal to 0. When S equal to 1 and R equal to 0, Q is 1, Q bar is 0. Okay. So this is called set state. And then the last one is when S1, A1 and R1. 0, 0, 1, 1. As you know, Q and Q bar are complement to each other. If Q is 1, Q bar should be 0. or if q is 0, q bar should be 1. But here q and q bar are equal at the same time. So it should never happen and it violating our complementing rule, right? So that's why this state is known as indeterminate state. When q and q bar is 1, so you should neglect the state, that means forbidden state or indeterminate state you can write. Forbidden. Okay. Now what will happen when enable is 0 is our question. Let us assume I think we don't want any inputs, right? Because NAND is sensitive to 0, it will provide output as 1, even though the second input is not mentioned and first input is 0. So it throws 1 here. Let us assume previous input as 0, previous output as 0, and Q bar as 1. Now these zeros come here. 0 into 1 is 0, 0 bar is 1, 1 into 1 is 0, 1, and 1 bar is 0. What is next state? 0 and 1. What you observe here, the output holds its previous output value when enable is 0, irrespective of any inputs given at S and R. Okay, so this is what you should know about enable or with enable and without enable. When I will write here one statement, when enable is 0, output holds its previous value. Okay, so this is about SR-Latch. So in order to avoid this state, we will use D-Latch. Okay, so let us see the functionality of D-Latch. We never get this state in D-Latch. Which state? This one state, forbidden state. Okay, let us see the D. So before what we have seen, we gave yes as one input to NAND, one NAND gate and OR as one input to other NAND gate. But here we are using only one input, but we are complementing the input and providing that complemented input to the other NAND gate. Okay, so let us observe its functionality only by truth table so that we can easily understand it. So this is enable and this is D input, it is Q and it is QR. Okay, okay. Let us see when enable is 0. And we don't want when enable is 0, automatically this is 0 and this is also 0 and is sensitive to 0. We don't want the D input at all or D as don't care here. 0. Let us see, this is 1, this is 1. Let us assume this as next and this as previous. Let us assume previous values are 1 and 0 and 1 comes to here, 0 goes to there. 1 into 1 is 1, 1 bar is 0. Next state Q bar output is also 0. 1 into 0 is 0, 0 bar is 1. Next state Q output is also 1. So based on this we observe that it is holding the previous value. So Q here, Q bar here. Okay, and then let me erase this. Okay, now enable 1, D1 I am giving. Okay, here 0, this is 1, this is 1, this is sensitive, the bottom NAND gate, so 1, this is 0, and this NAND gate is sensitive to 0, so it provides output as 1. This output comes here, and 1 into 1 is 1, 1 bar is 0. Always here Q bar, sorry, Q, that means output following the input. Okay, output is what? 1, and Q bar is 0. Now let us keep enable as 1 only, D as 0, and here 1, this is 1, this is also 1. This NAND gate is sensitive to 0, so it provides 1 here, and 1 into 1 is 1, 1 bar is 0 here. So this NAND gate is sensitive to 0, it provides output as 1 with irrespective of this input, and if it goes to here, 1 into 1 is 1, 1 bar is 0. So what you observe here is it followed again the input, the output is followed the input. So when enable is 1, D 0, Q followed the input, that means 0, and Q bar is 1. So this is about D-Latch. Instead of implementing D-Latch by providing inverter to another NAND gate, that is like this one, so that we can reduce cost, and we are implementing the same functionality as we saw before. So let us see whether it is working same as before or not. Okay, so let us see. It is enable, it is D, it is Q, or you can write even Q bar, Q bar. Okay, let us see first enable as 0, and we will assume next state and previous state outputs, and let us say previous outputs of 1 and 0. If enable is 0 here, 0 goes here and 0 goes here, irrespective of D input. D input here is don't care, we are getting output here as 1. Okay, now yes, previous state, this is previous state, output is 1. If it comes here, 1 into 1 is 1, 1 bar is 0. The next state output at Q bar is 0, and if it goes here, 0 into 1 is 0, 0 bar is 1. What you observe from here, the next state is equal to previous state. So Q and Q bar. Okay, and then enable 1, D1, 1 1, and 1 here. 1 into 1 is 1, 1 bar is 0, this 0 comes here. Now 0 into 1 is 0, 0 bar is 1, and this is sensitive to 0, so it provides output as 1. And if 1 comes to here, 1 into 1 is 1, 1 bar is 0. That means Q1, Q bar 0 when D is 1, and enable is also 1. That means here the output following the input. You can clearly observe it is same as previous situation. previous circuit diagram. Now D as 0 and enable as 1. Okay, this is sensitive to 0, so it provides 1. And if 1 comes here, 1 into 1 is 1, 1 bar is 0. This is sensitive to 0, so it is 1 here. And if it goes here, 1 into 1 is 1, 1 bar is 0. That means Q is 0 and Q bar is 1 when D is 0 and E is 1. So we can clearly observe that previous outputs or previous truth table is similar to this truth table, so that irrespective of wasting one inverter by putting it here, we can use this circuit diagram effectively. Okay. Yes. So this is the timing diagram. We will see it here. If previously we remembered what only two things. When enable is 0, D follows the previous output value. When enable is 1, D follows the input. Output follows the input. When enable is 0, output follows the previous output value. When enable is 1, output follows the input. I will write here. When enable is 0, output follows our output holds previous output value. When enable is 1, output follows the input. Just remember, D-Latch means this is the one you should get into your mind. Output follows input. Okay, so let us see. Here, see, enable is 1 and D is 0. Output should be 0 up to this time slot, right? And when D is 1, output is 1. Similarly, when enable is 0, the output followed the previous output value, right? When enable become 1 here, the output followed the input. Okay, so this is about D-Latch and its functionality. I hope you understood, guys. If you have any doubt, please let me know in the comment section. And also please like, share and subscribe to our Digital VLSA channel. Thank you so much. Bye.